All right, today we're doing something a little different. We're not just going to talk about software development right now. We're going to take a look at it from the future, and we're going to do it through the eyes of the very AI that's shaking everything up.
So I want you to hop in a time machine with me. Let's jump forward about a decade, just to get some breathing room, some perspective. We're going to look back at this exact moment in time, this wild period of massive AI-driven change that we're all living through. And here's the big question, right? When they look back, with the benefit of hindsight, what are future engineers going to say we got right? But maybe more importantly, what did we get completely wrong? What were the huge blind spots that we just couldn't see because we were right in the middle of it all? To figure that out, we ran a little experiment. We got 4 of today's top AI models. We're talking Gemini, ChatGPT, Grok, and Claude, and we gave them a prompt. We told them to act like professors from the year 2035 and analyze this era. And what came back was, well, it was shockingly consistent. And honestly, it's kind of a wake-up call for all of us right now.
This line from ChatGPT's analysis just nails it. It really frames the whole conversation perfectly. The big idea here is that AI didn't actually create a bunch of new problems. No, what it did was act like a giant magnifying glass, or maybe a blacklight, revealing the cracks that were already there in how we work, how we measure success, and how we train our developers.
So let's meet the panel. Let's introduce our AI analysts from the future and get their diagnosis of the years 2023 to 2025.
Okay, so check this out. Each AI gave this period a different name, but they're all pointing at the same thing. Gemini called it a cognitive efficiency crisis. Basically, writing code got super easy, but thinking clearly got way harder. ChatGPT saw it as a diagnostic phase, just revealing old wounds. Grok called out our perceptual bias, which is how we felt super productive even when the data said otherwise. And Claude, well, Claude called it the rise of comprehension debt, this massive gap between what our systems could do and what we actually understood about them. You see the pattern here, right? It's all about the disconnect between doing and understanding.
So let's dig into the first huge mistake they all pointed to, what they called the measurement mistake, or confusing the feeling of acceleration with actual, real progress.
And you know this feeling. On the ground, it felt like we'd strapped on a rocket pack. Everyone was talking about it. Developers were reporting feeling 20–30% faster. The tools felt great. You were just churning out code like never before. It was exhilarating.
But here's the kicker. Grok's analysis pointed to studies from the time that showed something totally different. When working in code bases they already knew, developers' task completion speed actually went down by 19%. There was this huge gap between how fast we felt we were going and what was actually happening. All that time we saved writing code was getting eaten up and then some by debugging, verifying, and just plain trying to understand the code the AI spat out.
And this really gets to the heart of it. We fell into a classic trap. We were measuring the easy stuff, the vanity metrics. How fast is the code flowing? How many tickets are we closing? How many features are we shipping? But the things that actually matter for building great, lasting software, like deep system understanding, good judgment, and maintainability, those were getting ignored because, they're hard to put a number on.
And this obsession with speed, well, it wasn't free. It came with some serious consequences. It led to these new, sneaky kinds of technical debt that were going to come back to bite everyone.
The first one is what they called logic debt. And this stuff is so insidious. The code looks perfect, it passes all the checks, the linter's happy, but it just doesn't do what you think it does. The logic is flawed. It's a bug in the meaning, not the grammar. And this just exploded because our human speed code reviews had no chance of keeping up with machine speed code generation.
But then there's something maybe even more dangerous: comprehension debt. This is the ever-widening gap between what a complex system is doing and what any single human on the team actually understands about it. Here's a simple test for you. Think about your system right now. If the person who wrote it left tomorrow, how long would it take a new developer to safely make a change? If that answer is getting longer and longer, your comprehension debt is going through the roof.
And this wasn't just some abstract concept. This debt had real painful costs. Teams had what they called brittle velocity. You move super fast, then you hit a wall and everything grinds to a halt. Security bugs shot up. And we saw the rise of the hollow senior, an engineer who looks great on paper, closes tons of tickets, but when a real crisis hits, they don't have that deep intuition to fix it. And maybe worst of all, we started to burn the ladder for junior developers, who were losing the chance to learn crucial skills like debugging from the ground up.
This all leads to the next big finding from our future professors, a huge crisis of misprioritization.
For a while there, the whole industry just started valuing the wrong skills.
I mean, for a hot minute, everyone was obsessed with becoming a prompt engineer or mastering the newest tool. It was all surface-level stuff. But our AI analysts are basically screaming back through time at us, saying the skills that actually mattered, the ones that made a real difference, were the timeless, fundamental engineering skills. Things like being able to write a crystal-clear spec, being able to debug a nightmare problem that crosses 5 different services, and having that gut-level intuition about how systems work.
I absolutely love this quote from Gemini's take. Access to infinite syntax does not equal infinite engineering. It's so true. Just because you can generate endless lines of code for free doesn't mean you've solved the hard problems. The real work of engineering, design, trade-offs, reliability, that stuff doesn't go away.
Okay, so it sounds a little bit grim, I know. But here's the good news. The profession didn't just drive off a cliff. Eventually, it adapted, it course-corrected, and a new kind of developer started to emerge.
The first big change was a shift in identity. The most valuable people were no longer the ones who could write the most code. They were what they called editor engineers. Their value came from their taste, their judgment, their ability to curate and simplify, and most importantly, to reject bad ideas. The most powerful word in their vocabulary became no.
And this led to something called the Great Differentiation. The old monolithic idea of a full-stack developer started to splinter into more specialized roles. You had implementation developers who were wizards at turning a perfect spec into clean code. You had system developers who were responsible for how all the pieces fit together and behaved in the real world. And you had specification developers whose superpower was talking to humans and translating messy business problems into flawless technical plans.
And all of this brings us right back here, to today, to us. This whole thing isn't just a fun story about the future. It's a warning. It's a set of really tough questions being sent back to us in a time capsule. So first question, and you've got to be honest with yourself. Are you on the path to becoming one of these hollow seniors? Are you leaning so hard on the tools that you're forgetting how to think from first principles? Are you building the skills to rescue a system when it's on fire, or just to build the next shiny new thing?
And the second question is for your team, for your whole organization. Look at what you celebrate. Look at your metrics. Are you optimizing for speed above all else? Is it anyone's actual job to just understand the whole system? Or are you right now building a beautiful, complex machine that nobody on your team truly gets?
Because in the end, the big takeaway from our future AI professors is this. The tools are not the problem. They never were. The problem is what we choose to value. It's what we decide to measure. The AI didn't create this mess. It just held up a mirror and forced us, finally, to take a good, hard look.
Before you head out, let me leave you with a small ask. If this video made your .NET brain spark even a little, hit that like button. It takes you 1 second.